Hello everyone, thank you so much for being here. My name is Kratzer, and I will be talking today about why citizen science has never been more important than it is right now. Many of you may already be familiar with the concept, but citizen science is a voluntary scientific initiative that does not require any special training or expertise. It is a model for science where everyone can participate, regardless of individual background, and stands in contrast to the way science is traditionally depicted, as something that can be done only by specialized researchers in specialized labs. Let's take a look at some of the benefits and drawbacks of citizen science as a tool for researchers. Citizen science can produce and analyze enormous amounts of data proportional to the number of active participants in a project. Citizen science provides ample opportunities for hands-on learning by asking participants to be a part of the process. It builds communities around a shared interest in science, and it helps to remove barriers to specialized fields by giving everyone a chance to directly interact with the scientific method. All that said, citizen science is not always a good solution to every problem. It works well when quantity is much more important than quality. Even if 100% of the participants are dedicated to the project, untrained people will tend to submit lower quality data than trained specialists. Whether or not that's still useful depends on the area of research. You'll also tend to see over and under sampling issues in the data. In larger projects, some users and regions will produce far more data than others due to a variety of factors, which your statistics will have to account for. Let's look at some examples of successful citizen science projects to get an idea of what they are and how they work. TIDES, or the Trash Information and Data for Education and Solutions, is a global project to document litter and trash in the environment. Its original focus was to monitor trash along coastlines, but it has since expanded to include all ecosystems. Policymakers use data from trash monitoring projects like TIDES to make better regulatory decisions, so this kind of data is extremely important. Topical issues include plastic bags and cigarettes. Zooniverse is a platform that hosts a collection of about 100 active citizen science projects. With over 1.6 million registered users, it seeks to apply citizen science to topics as diverse as astronomy, physics, biology, medicine, and history. Citizenscience.gov is a collection of citizen science projects run by departments of the U.S. government, including the NOAA, the EPA, and the Park Service. Participation may be limited to people within the United States. Folding at home is unique in this list, because instead of involving you, it only requires your computer. Folding at Home is a background application that uses the processing power of thousands of computers worldwide to create a virtual supercomputer, which it uses to model the complex interactions of proteins. Folding at Home is particularly topical this year because they have a dedicated initiative for the proteins found in COVID-19. The search for more effective treatments could be as simple as leaving your computer on overnight. And finally, this list wouldn't be complete without iNaturalist. iNaturalist is a platform where you can upload photographs of organisms around your neighborhood to contribute to variation, behavior, and locality data. iNaturalist is not unique in this respect. There are many platforms like it, including eBird and Bug Guide. But what sets iNaturalist apart is its truly global scope, and the fact that it uses AI to guess the species present in each of your photos. For no particular reason, and certainly no personal bias, I'd like to take the rest of this presentation to explain why citizen science initiatives that focus on biology are especially important right now. So brace yourself for rampant oversimplification, because I'm going to try to explain some of the biggest issues in ecology in under 5 minutes. Let's go. This is a very simplified food web, where organisms interact to obtain the nutrients they need to survive. But there's more to this picture than we typically think about. For example, the plants that grow here are dependent on the soil, and the soil is ultimately dependent on the underlying geology. And, of course, all of the organisms are dependent on the local climate. Let's think of these organisms not as brush, mice, and hawks, but as generalized organisms that have increasingly more ability to move around. And let's place them in the context of their adjacent ecosystems. Towards the left are hotter climates and lower elevations, and towards the right are colder climates and higher elevations. Each group of organisms has adaptations that help them survive in their own environments. Now let's watch what happens as the climate warms. Organisms that can move more easily can keep pace with shifts in the climate, but organisms that can't get left behind. Vegetation that directly depends on certain soil types can't move because that soil is tied to the local geology, and the rocks aren't going anywhere soon. Every food web gets shifted, which places stress on every ecosystem along the way. Let me explain what I mean. Can the predators survive in a different habitat? Can the predators survive with new prey? Can the herbivores survive with new predators? Can the herbivores survive in a different habitat? Can the herbivores survive with new vegetation? Can the vegetation survive with new herbivores? And can the vegetation survive in a warmer climate? Even if the answer to all of these questions is yes, the pressure to suddenly adapt to new circumstances increases systemic stress. Speaking of systemic stress, invasive species are organisms that are introduced to an area outside of their native range. They lack natural predators, parasites, and diseases, which allows them to outcompete native species. This often has a destabilizing effect on the food web, which reduces an ecosystem's ability to store and process nutrients. Some invasive species have effects beyond the food chain. Most of North America has no native earthworms or woodlice. I know you've probably been told that they're good for the soil, and while that's true for their native habitats, here they dramatically speed up the rate of decomposition, which releases tons of greenhouse gases and makes it hard for forests to regrow. Invasive bivalves like zebra mussels do something similar, but in water. They filter out nutrients faster than anything else can keep up, starving out native life. Another major environmental stressor is the rate at which land use changes and habitat is destroyed. Forests are cleared for farmland, dams flood valleys, urban sprawl swallows the desert. These changes are happening much faster than organisms can adapt to them, and we can watch it happen on the span of human lifetimes. Of course, all this is compounded by the compounds we're unintentionally throwing into our ecosystems. Solvents, fluorocarbons, hydrocarbons, heavy metals, salts, nitrous and carbonic acids, and plastics, to name a few. That's also a mess, and that also contributes to systemic stress. And finally, there's never just one extinction. Take the ash, elm, and chestnuts of eastern forests. They're not extinct, per se. You can still find them in the wild, but their numbers are so reduced due to pest and disease that they risk losing their ability to perform their ecological functions. The fungi, insects, and birds that depend on them are doubly affected by the tree's decline. No species exists in a vacuum. Except tardigrades, but that's only when NASA launches them into space. You get the idea. So, why do we care about biodiversity in the first place? Well, biodiversity works as redundancy to stabilize our ecosystems, and our ecosystems provide us a lot of essential services. Things like carbon sequestration, erosion control, flood control, pest control, air filtration, water filtration, agriculture, and aquaculture, to name a few. And even if none of that appeals to you, evolution is a learning algorithm that has been running for the past 4 billion years. Nowhere else will you find a better model for solving problems on the planet Earth. As engineers, we stand to lose precious knowledge if we do not place value in biodiversity. So, here's the problem. I'm really fudging the numbers here, but there's about 500,000 biologists in the world and somewhere around 10 million species. That means there are something like 2 times 10 to the 12th possible interspecific relationships on each major continent. That wouldn't be a huge problem on its own, except that we are running out of time. Instead of measuring species decline in geologic epochs, we have decades. and we stand at the precipice of a mass extinction. Luckily for us, this mass extinction couldn't have come at a better time. Our technology now allows us to store and process huge amounts of information, and our global connectivity gives us access to the power that comes with citizen science. Mass extinctions aren't new. Earth has suffered 5 of them before, but this is the first time we have the ability to fight back and preserve the life on our planet. And that brings me back to iNaturalist. Uploading photos here isn't just fun, though subjectively it is. It contributes to a growing understanding of the relationships between organisms on our planet. We won't be able to save every species. We've already lost a great many. But the information we collect allows scientists to use their resources more efficiently to stabilize as much biodiversity as we possibly can. Remember that humans are remarkably good at solving problems, and even better at solving problems that they know about. Like I said before, iNaturalist is a global network, and I've seen firsthand how its data can be used. I invite you to join me in making the world a better place, one photo at a time. Or, since we have digital storage now, maybe like 100 photos at a time. Contribute as much or as little as you want is what I'm trying to get across. Speaking of which, I have a very special announcement to make. Some of you may remember when we ran a biodiversity competition at RIT back in 2018. Well, now we're doing that for the whole continent. Introducing ESW-Bio 2020, a citizen science competition between all ESW chapters. It begins today, and it ends 1 week before next year's ESW-Con. It's managed through iNaturalist, so all observations from your campus are automatically included here. You do not have to be an ESW member to participate, and there will be awards. I'm very excited about this, and you'll see another announcement about this later on today. Thank you so much for your time today, and please feel free to check out any of the amazing ways you can get involved in citizen science here on this page. I'll be around to answer any questions that you have. Have a great day, and stay safe.